Now we're going to talk about some labor-saving devices. Suppose we want to find the definite integral from -1 to 5 of this function right here. First, I would hope that you can look at this function and immediately recognize that this tells us that it's going through -2, 6. So there's a point. And this right here is our slope. So it goes down 1 over 2, down 1 over 2, down 1 over 2, and so on. So our curve is going to look something like that. And then the problem asks us to find the definite integral from -1, which would be right here, to 5, which is right here. We're bounded below by the x-axis. So we're looking for this area right here. Now in the case of this problem, I would not break it up into a bunch of little rectangles, because what we're looking at here is a trapezoid. In this trapezoid, one of the bases has a height of 5.5, and the other base has a height of 2.5, and this height right here is a length of 6. So we can find the area simply by using the formula 1/2 the height times the sum of the bases, which would give us 1/2 times the 6 times 5.5 plus 2.5, which works out to give us 24 is the area bounded under the curve. Symbolically, we should know to write this as our x values start at 1 and they end at 5. We're taking the sum of our f function times the change in x, that's pretty much always the same, is equal to 24. Let's look at another example. This right here is called a piecewise function. And so it splits at 4, and this is telling us that until we get to 4, the function always has a value of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then at x equals 4, it also has a value of 9. Now if you look at values larger than 4, it's a quadratic function. So I'm going to plug in a few values. I'm actually going to work backwards starting at 7. If I plug in 7 here, we get 0. If I plug 6 in here, we get, let me pull this up so you can see better. If we plug 6 in here, we get 1. If we plug 5 in here, we get 4. And if we plug 4 in here, we actually get 9. So the curve looks something like this. It's sort of like Pike's Peak or something like that. And the problem asks us to find the area under the curve from 0 to 7. And so what you would want to do in this case is start by saying, well, this right here, this is clearly a rectangle. And I know this rectangle has a base of 4 and a height of 9, so this is going to be 36. This curve right here, this parabola, on the other hand, I don't know any formulas for that. So here, we're going to have to divide it up into rectangles. And again, as you're drawing your rectangles in, you want to pick a height so that the part that you catch and the part that you miss are about the same. Same thing here, and then same thing here. So I'm going to estimate that this right here is about 1, 2, 3, 4, 5, 6.2. And this right here is 2.1. And this right here is 0.6. So our definite integral will be 36 plus 6.2 plus 2.1 plus 0.6. And that's going to add up to give us, let's see, that would be 2.7, 2.9, 8.9. On top of that, I'm getting 44.9. Last thing, So I want to remind you how to write this symbolically. We say what we just did is we took the sum of the function times the width. Now the function in this case was called h of x, and the width is always going to be dx. We did this starting when x was 0. We stopped when x was 7, and our final value was 44.9. On the back side of this page, there's a good problem, but it's not a problem that I'm going to go all the way through in this video. So what I am going to do is just flip the page, and I'm going to give you these answers. And then you can work through it at your leisure. So this one's 5 miles per hour. This one's 19.63 miles. The next one is 16.07 miles. The next one is t equals 14. And the last one is 32.56 miles. The end.